Hello, this is Susan Poss. We're going to be working again on solving linear equations. These are just a little bit more challenging than the previous ones, so this is section 2.4. The steps outlined here are combined like terms that are on the same side, so we'll be looking for variable terms that match and constant terms that match. Second, we're going to try to isolate the variable term on one side, and we'll be using our addition principle to move terms from side to side as needed. And finally, we'll be using the multiplication division principle to make the coefficient on the variable term equal to positive 1. So the first example, I'll try to leave those steps there so you can see them for just a minute. I don't see any like terms that on either side here that need to be combined. I do see there's my equals mark, so that's my separation between left and right. And I'm going to now try to isolate this variable term. So here's my variable term. I do not want that positive 10, so I'm going to subtract that away from both sides to maintain the balance. That will bring me to 3x equals negative 15. All right, so I've managed to isolate the variable term. The next step then is to use my multiplication or division principle to make the coefficient on the variable term, so I want that 3 to be a positive 1. And so that's where we come through, and we're going to divide by whatever that coefficient is in front of the variable term so that we get that to cancel out, produce that positive 1 on the variable that I'm looking for. And then, of course, on the other side, you see when I do the arithmetic, I end up with positive 1x equals negative 5. And so I'm finished. I haven't talked about checking before, but if you were working on a test or a quiz and you wanted to check this, you would just run all the way back to the top, pick up the equation in its original form, replace the letter x with whatever you found the answer to be, follow your order of operations, and if you end up with a left side balanced and equal to a right side, then you know that your answer is correct. So here's another one I wanted to try with you. This particular one, again, let me separate so you see left side and right side. You can see the left side has 3 terms on it. And I'm noticing as I look at those 3 terms that there are 2 constant terms over there, which are alike. So I'm going to copy down the positive 5x. I'm going to combine the positive 5 and the negative 6 to get negative 1. Now my goal is to isolate the variable term, so I'm going to move this 1 away from the variable term by using an inverse opposite operation. And of course do the arithmetic over there on that side. 9 plus 1 is 10. And the final step is to take the multiplication or division principle and divide each side by that coefficient that you see there on the x term. And again, the reason I'm doing that is so that these 5s will cancel out and give me a positive 1. Well, I was working this in red. So you can see I have the positive 1x, there it is, it's still over there on that side, equals, and then 10 divided by 5 is 2. So I've successfully solved this for the variable x. Here comes another one that is kind of heavy on the right-hand side of this equation, and I'm noticing 2 terms here on the right side that are alike. So I'm going to go ahead and combine those 2 terms. Next, I want to try to isolate this variable positive 6y term, and the way I'm going to go about that is to move away by subtracting away, or adding a negative if you want to think of it that way. So as I do the arithmetic, I can see on the left-hand side I get negative 36. Here's my equals mark. I'm bringing down the 6y, and of course you can see that the positive 16 and the negative 16 here add up to 0. So the last step is to, again, focus your attention on the variable term, and you want to divide out the coefficient of that variable term. So as I do that, you can see that these 6's divide out to give me that positive 1 that I'm looking for. Let me come over here to finish it. I don't have enough room down here underneath. So on the left-hand side, I see negative 6. Here's my equals mark. And on the on the right-hand side, I see positive y. So I've successfully solved that one for positive y is equal to negative 6. Again, quickly, if you wanted to check this one, you would go back to the original equation, and everywhere you see a y, you would plug in your answer negative 6, and then you want to do the arithmetic to make sure you have something that's balanced on the left and the right. And it looks like I have negative 20 on the left and I have negative 20 on the right, so that looks fine to me. All right, so I wanted to skip over this next one, come down and do a couple of quick fractions with you. So as I look at this first one, I don't have any like terms on either side, that I can combine or add or subtract. So here's my equals. That's separating left side from right side. I'm noticing this is my variable term here, and what I would like to do is to eliminate that 4 and move it away from the variable term, because one of the things I want to do is isolate the variable term. And this was going to require a little bit of work. And again, if you know how to use the fraction key on your calculator, you go right ahead and do that. I'm converting these into fifths to get a common denominator. So 9/5 subtract 20/5 is negative 11/5. Let me go back over here and not lose the left side of my equation. Here we go, and I'm going to need a little more space for this. So if you remember, let me head up this way, when we had in some of our previous work, we had a coefficient on the variable that was a fraction. We inserted these brackets around the equation, and we came back in and we multiplied by the reciprocal of, whoops, that's not the reciprocal. We multiplied by the reciprocal of whatever the coefficient was on the variable term. Why did we do that? We did that so that these would all cancel out and bring us to that positive 1x that we were looking for. And then on the left-hand side, let me write this again so I can show you my work. I can see that those 5's are going to cancel out. So it looks like my answer here will be negative 11/3. All right, so one last one before I stop this. On this last one, I'm looking at the left-hand side. Again, let me draw you my dotted line here so you can distinguish left side from right side. On the left-hand side, I see 2 terms that are alike. So I'm going to go over here to the side, and I'm going to combine 8/3 and 2/1. And again, I want to get these both in terms of a denominator of 3. So I'm seeing 8/3 plus 6/3. This looks like 14/3. So these two combine to give me 14/3. I'm copying down the variable term. Here is my equals mark, and on the right-hand side, I have the 6. All right, so my next step is going to be to isolate the variable term, and in order to do that, that 14/3 needs to go away, so I'm going to subtract it away from both sides, which successfully isolates this negative 7/3 x. That's my variable term. And let me go off here to the side. I'm going to take 6/1 and subtract 4. Whoops, I didn't leave enough space. Let me try that again. I'm going to take 6/1 and subtract 14/3. And again, I want to go and convert this all into thirds, so I have a common denominator. So this looks like 18/3 minus 14/3 is 4/3. So all of this over on the right-hand side. These two, when I combine them here, I end up with 14/3. All right, so we're almost done. Again, I've got a variable term that has a fraction, so I'm going to use my bracket technique, and I'm going to multiply both sides by the reciprocal, and notice that the reciprocal maintains the same sign. So if you're working with negative 7/3, the reciprocal is negative 3/7. So I'm multiplying both sides by that reciprocal, and of course you can see that that negative times negative, and when all this cancellation occurs, will bring me to the positive 1x that I'm looking for. And on the other side, I can see these 3's are going to cancel out. So it looks like on the right-hand side, here's my equals mark, I'm going to get a negative 4/7. So again, successfully isolating the variable x, I've got a positive 1 coefficient here, and so I'm done. I hope that helps you as we move along through equations.